All right, so lesson 9 in your textbook says it's going to cover squares, cubes, and Pascal's triangle. It barely discusses the triangle bit, and so we're actually going to save that till later because it's not really necessary. So really, what we're going to focus on is going to be squares and cubes. And you've actually done this before, I believe, last year. There's just a couple of formulas that you're going to need to jot down so you have to work with your homework. So you've seen problems like this for a very long time. X plus 4 squared, and we know that that squared means there's two of them. And so the longhand way to do this is to just spread it out, x plus 4 times x plus 4. And remembering that when we do this, you can use the FOIL method, which is probably the most prevalent method. I just sort of take the first term and multiply it to both parts, take the second term and multiply it to both parts. And when I do that, I end up with x, I will walk through it. X times x is x squared. X times 4 is 4x. 4 times x is 4x. 4 times 4 is 16. And then these two terms are like terms because they're both x. Remember, this doesn't match exactly, so it's not a like term. It has to match letters and exponents. So then I just add those 4x's and I end up with x squared plus 8x plus 16. And so there's this little pattern here when you have something squared, and that we notice we can add 4 plus 4 is 8. We can also multiply. 4 times 4 is 16. So we're basically backwards factoring to put it back together. And this formula is written a little scarier than it needs to be, and it's always an AB. The formula, if you're squaring something, if it's a plus b, then it is a squared plus 2ab plus b squared. So let's walk through what that looks like in this problem that we just walked through. And the truth is, I rarely ever use these formulas for squaring it. It's quicker for me to just work them out than it is to stop and process through all of this. So if it's easier for you just to work it out, that's fine as well. All right, so let's look at this problem we did before. So we have, this would be then our A, and this would be our B. So in our answer, a squared is first. X squared. There it is. Then 2 times a times b. So 2 times a, 2x, times b, 2 times 4 is 8. So 8x right there. And then the third is going to be b squared. Well, in this case, b is 4, and 4 squared is 16. If you're subtracting, you do the same thing. You just make it a minus right here over a plus. Again, I honestly think it's quicker for my brain to just write out x plus 4 times x plus 4 and do it than try to stop and recall this formula. But there are a lot of people who prefer the formula. So let's do a couple using that formula. So I put the formulas on top of this slide so that we can see them. And then we're going to work these two problems. So let's work through x plus 3 squared. So it's a plus, so we're going to use our top equation. And the first thing it tells us is the first term is going to be a squared. So remember, this is your a and your b. A squared is x squared. And then 2 times a times b. So 2 times x times 3. 2 times 3 is 6. And then b squared. So 3 squared is 9. So that is my first problem worked out. And now let's look at our second one. And you need to just pay attention to your sign there so you can make sure that you have the right formula. Sorry, my brain shut down what I was saying. So this is a minus, so we're going to use this. It's still a squared. It's still a b, so it would be y squared minus 2 times a times b. So 2 times y times 9. 2 times 9 is 18, and that y, so minus 18y. And then plus b squared, well, b is 9, and 9 squared is 81, so plus 81. And that is it. Again, I don't really like this formula. For me, it's just easier for my brain to work them out. So the truth is that however you get to the answer is how you get to the answer. Now the cubed one that we're fixing to look at, I usually do use because, well, you'll just see. But before we get to that, let's look at working this a little backwards. So let's say that I already give you a trinomial, x squared minus 16x plus 64. And I'm asking you then to find the binomial, which is a two-term, root of the following. So basically we're going to work this backwards. So we need two numbers. Nope, that's not true. We need one number that is going to get us, when added, 16, when multiplied, 64. For my brain, the easiest thing to do is to take that middle term, the x term, the term that does not have the x squared but just the x, and divide it by 2. Negative 16 divided by 2 is 8. So then the answer is just x minus 8 squared. So if it's asking you to find the binomial root to work these backwards, just take that middle term with the sign and divide it by 2. I'll be honest, this is like the only curriculum I've ever seen have you work it that direction, but it's in there, so we'll do it. Let's look at one more just to be cautious. So x squared plus 10x plus 25, and we're asked to find the binomial root of the following. So we're going to divide the x terms, the 10x, by 2. 10 divided by 2 is 5, so it's just x plus 5, x plus 5. And the truth is you would probably not write your answer that way. You would more likely write it like this. So that one's really, really simple. And again, I've never seen it done that way, just this curriculum. I don't really know well, it's just a quicker way to factor it, but that only works on certain trinomials, so that's a little bit odd. Now cubing is where this gets a little wonkier. So normally when you have this, you're going to write out x plus 5 times x plus 5 times x plus 5. You're going to factor this whole thing and then end up with a really long something there, and then do that again to this and have to FOIL that out or multiply it out over and over and over, and it's long and tedious. Now if you don't remember this formula, you can do it that old school way, and it's really not an old school way, it's just the original way to do it. But there are formulas that you can use. The truth is I don't even have never done this very often. I have cubed this before, but nowhere near as much as squaring it. So the formula for cubing, if it's a plus b, a cubed plus 3 times a squared b plus 3 times ab squared plus b3. And same thing there for the minus. It's just that some of that is subtraction instead of addition. And that is a lot of like numbers and variables and exponents to spit out at you all at once. So I think the best thing for us to do is just to do one. So let's talk about this x plus 5 cubed. So a, b, term 1, a cubed. Okay, I'm going to erase that so we can always see where we are. The second one is 3 times a squared b. So plus 3 times a squared is 3x squared times b. b is 5. So 3 times 5 is 15 x squared. And because I have the beauty of this pen, I can erase that. Then the third term is 3 times ab squared. Don't kind of think you can write the same thing twice, because this one is a squared while this one is b squared. So times 3a b squared. Now b is 5, so 5 squared is going to be 25. 3 times 5 is 75, so plus 75x. See, these are just tedious. The math is not hard, but I don't enjoy these. And I enjoy math, so sorry that you have to do this. plus b cubed. Well, 5 cubed is 125. And that ugly thing is your answer. And the truth is, this looks much simpler than the other one. So sometimes in algebra, it's not about getting it simpler. Sometimes it's about spreading it out in order to use it in a different way. So this lesson is about spreading it out versus it's kind of more confusing than when you started. So if you'll jot these formulas down, we're going to look at a subtraction one real quick, just so you can kind of see it one more time. All right, so this one is a subtraction one. And so we're going to use the second equation or formula, but it also has two pieces here. So you need to just kind of watch that, because when there's two terms there and you have to square it or cube it, you're going to have to cube all of that. So my first term is a cubed. This is all a, so 3a times 3a times 3a. 3 times 3 times 3 is 27. A cubed. All right, now minus 3 times a squared times b. So 3 times a squared is 9a squared times b, which is 4. And this gets really tedious, and I always write this down. Now, I have some kids who do these and can do it in their head, but I have to write this down. So again, it's 3a squared, well, a is 3a, so 3a squared. 3a squared becomes 9a squared times b. And that, when it's all sort of put together, 3 times 4 is 12. Whoops, let me actually grab my calculator, because that's going to be a pretty big number there. So 3 times 9 is 27, but 27 times 4 is 108. So minus, oh, my pen, there it goes, minus 108a squared. All right. And then my third piece is 3 times a times b squared. Well, b is 4, so 4 squared is 16. 3 times 3 is 9. 9 times 16 is 144. And then I have my a. And then my last term is b cubed. Now my last term is just 4. So 4 cubed, 4 times 4 is 16. 16 times 4 is 64. So plus 64. And there are no like terms there, so that big old ugly thing is your answer. And I don't believe, let me just look real quick. Yeah, you're not going to be asked to work these backwards. That's a little bit too much. Hopefully that makes sense. And like I said, if you don't really feel comfortable using these formulas, just write them out and work them out. I have some kids who despise the formulas. The truth is, I would rather work them out the long way. It's just easier for me to remember one way that always works than learn formulas. But if these help you, then go for it. And I put in the email that the homework is going to be, it's called, it's not the systematic review. My brain just shut down. Lesson 9A. I don't think it's lesson though. Yeah, lesson 9A practice. You're just going to do numbers 1 through 14. You're not going to worry about 15. All right, let me know if you have any questions.